Hello everyone, you are welcome to today's session. So we are going to continue with remainder theorem. We've looked at the functional notation. If you want to understand it, kindly go back to our previous video and look for lesson 5 and you get understanding of what the functional notation is about. So now we are going to look at the remainder theorem. I'm going to make it very brief for you. The whole idea of the remainder theorem is to help you to get the remainder when you are dividing without necessarily using the long division. Okay, so let's look at this one for instance. See, when I taught you guys the division, I said when you have a fraction, and I even went on to explain the improper fraction and the proper fraction. I said the improper fraction when the numerator has the highest degree compared to that of the degree of the denominator. We say that it is improper. All right, so here, let's divide it and see. You have x cubed minus 7 square plus 6x minus 2. And we have to divide using the long division. So this is x minus 2. This is the divisor. All right. Now, this one will come and divide this, giving you x squared. Then you have this one multiplying. That will give you x cubed. The same x squared will multiply this, giving you negative 2x squared. So you divide. So you subtract. X, the negative will affect the x cubed. All right. And that will become x cubed minus x cubed, so that will be 0. Okay, so here will be 0. Then the negative will affect this one, but negative will be positive plus this one, so that will become negative 5x squared. It will reduce it. All right, then you bring this one, that is plus 6x minus 2. Then this one will come and divide it. Now when it divides it, what do you have? You have, that is neg 5x. Then it will multiply it again, giving you neg 5x squared. Then this one will also multiply, giving you negative, that will give you plus 10x. Okay, so you subtract. Negative will be positive, plus this negative, and that will give you what is 0. The negative will affect this one. Okay, so that will become neg 10 plus this, so you have neg 4x, then you bring the 2 over here. I hope you are following. The x will come and divide this, giving you neg 4. Then you multiply half neg 4x. The same x, so if neg 4 will multiply this, giving you plus 8. All right, so you introduce the negative again that you are subtracting. Positive plus this, and that will give you 0. But the negative will also affect this one. All right, so what is it giving you? It is giving you, that is negative 8 plus this one, and that will give you negative 10. So what it means is that this is the remainder. Okay, and when we're looking at the fraction when it comes to the polynomial, we say that when you have an improper fraction like this, and you have the function f of x, it becomes the quotient. This is the quotient plus the remainder divided by the divisor. Do you know that? Are you following? Do you know that you can rewrite this one as f of x equal to q times d plus r? So how do you go about it? You multiply both sides, and this one will cancel, so become QD. And that's why you have it this way. Now, the D is the divisor for this question. So if you want to find the remainder without going through this long process, what you are going to do is that this D, which is this one, which is x minus 2, you are going to equate it to 0. So you have x equal to 2. Then you come and put x equal to 2 into this one, so that will become 2 minus 2, and what do you have? 0. Meaning that this side is 0. 0 times the k will give you what? 0. So that means that what will be left when you put the value of x, that is the remainder, when you equate it to 0 and you put the value of x of whatever figure that you get into the expression, whatever that you get will give you what? The remainder. Now you can see that this process is very long. All right. So how then do we go about it quickly, especially if it is objective? And that is where the remainder theorem actually what comes in. So now let me try to use the remainder theorem to solve this same question to see whether we will get a remainder which was that is negative 10. You have f of x, which is this one. You've already established that the divisor you equate it to 0, giving you x equal to 2. So you come and put it inside here, which is 2 exponent 3 minus 7 2 exponent 2 plus 6 2, then you have 2. This one will give you what? 8. Now what do you have over here? 2 is 4 times this. That will give you like 28. I hope you are following. Then what do you have over here? This one will give you 12. Okay. So what do you have here? 2. This plus that will give you 20. This and that will give you like 30. And when you do your deduction, what do you have? You have like 10, which is similar to the remainder that we have when we use the long division. And so the whole idea for the remainder theorem is what I've simplified over here for you. All right. So now can we look at this question? They are saying that what is the remainder theorem when f of x is divided by this? So you start by saying that x minus 1 to be equal to 0. You have x to be equal to 1. So you have when f, because look at it, is f of x, but we have established that x is equal to 1, so you put it inside. Meaning that here x cubed, so that will become 1 cubed minus 3, and you have 1 square, all right, plus x, which is 1, minus 5. So what do you have here? This one will give you 1. 1, because 1 times 1 times 1 is 1, and that is why it's like that. So here 1 times 1, which is 1 square, will give you 1 times this. That will give you like 3. All right, and this side too will give you plus 1. Then you have like 5. So when you put this one together, that will give you 2. This one together, that will give you like 8. And when you simplify, you have like 6. Meaning that the remainder is what? Like 6. And this is how you go about using what? Remainder theorem to work it out. All right. Now, how can we be so sure that when we go by the normal long division approach for dividing polynomial functions, we'll get the same answer? So I hope you've now seen how. Let's write the answer down, which is like 6. Okay. So let's go by the long division approach. You have, that is x cubed minus 3x squared plus x minus 5. Then the divisor is x minus 1. All right. So let's look at it. Let me change the marker. Now when this one divides this, what do you have? X squared. X times this, that will give you x cubed. Then the x squared will multiply what you have over here. All right. Giving you, that is neg x squared. All right. Then when you deduct, what do you have? It will cancel, the cube will cancel, so you have 0. But the square, sorry, the negative will make it positive. But it will reduce this one to negative 2x squared. Then you bring your x here, minus 5. X, divide this one again, and you have like 2x. I hope you are following. So then the 2x will multiply the x, giving you another like 2x squared. The same like 2 will multiply this one, that will become plus 2x. So you deduct. negative negative will make it positive, but when it is positive here and here is negative, that will become what? 0. The negative will affect this one, giving you neg 2 plus this, so you have neg x. All right, then you have, that is 5 over here. Now let's look at this one too. X divide this one, you have neg 1. Neg 1 multiplies this, you have neg x. Neg 1, that will give you, that is 1. Then you subtract. The negative negative affect this one. What do you have? Positive. Plus the negative, you have 0. Then let's look at this. Negative negative, that, sorry, positive negative positive, that will be negative. So here will become neg 1 plus this neg 5, and that will give you neg 6. So meaning that the remainder is neg 6. And when you use the long division approach, this is what you are getting.